Hello everyone, welcome back to Coding Charms, and in this video we are going to be solving the problem construct binary tree from Inorder and Postorder Traversal. And in this problem we are given with two integer arrays, Inorder and Postorder, where Inorder is the Inorder traversal of a binary tree and Postorder is a Postorder traversal of the same tree. And what we have to do is we have to construct and return the binary tree. So we know that we have four tree traversals. The first one is Inorder traversal, and the second one is the pre-order. Third one is the post-order, and fourth one is the level order. So Inorder is basically we first visit left, then we visit root, then we visit right. And pre-order is first we visit root, then we visit left, then we visit right. Post is the name describes we visit the root in the last post, left and right. First we visit left and right, then we visit root. Level order traversal is level wise. First we visit the first level, then the next level, then the next level. Okay, so we are given with Inorder and this post order traversal, and we have to build the tree and return the root of the binary tree. So let's take a look at the example. So we have this example. We have given it's Inorder traversal, the trees Inorder traversal and post-order traversal, and we have to return the tree itself. In LeetCode, they represent the tree as the level order traversal. So this is the level order traversal of this tree, if you can observe. So let's take a look at the example. I have taken it here. So this is the Inorder traversal given to us and post-order traversal given to us. And Inorder is left root, right? And post-order is left, right, root. So if you observe, from Inorder and post-order, can we determine the root of the binary tree? Just the root. We can, right? The last one in the post-order will be the root. So left, right, root. So this will be the root. So we know what's the root of the binary tree. Root of the binary tree is 3. Okay, so now we have found out the root of the binary tree. This guy is the root of the binary tree. And we don't know where the root exists because it exists somewhere in the middle. So now what we do is we figure out we take this root and we figure out where it is in the Inorder traversal. It is here. So we find that index. In Inorder traversal, we have root in the middle. Then all the left portion is the left subtree and all the right portion is the right subtree. So this all comes under the left subtree. I'll mark it as blue, and this all comes under the left subtree. I'll mark it as green. Okay, so this is the left subtree and this is the right subtree. So we pass it over to the, so we pass this is the Inorder traversal of the left subtree. So we pass it over here. Let's take, let me draw its subtrees, and here we pass 9, and here we pass 15, 20, and 19. So 15, 20, and 19. This is the Inorder traversal. And coming to the post-order traversal, how do we determine what is the left subtree post-order and what is the right subtree post-order? If you can see, the post-order traversal will have same nodes as the nodes in the left subtree will be same. So the length of the Inorder traversal will be the length of the Inorder traversal of left will be equal to length of the post-order traversal of the left subtree. So here the length is only 1. So we can say this one as the left subtree post-order traversal. So let me mark it as blue. Oh, I have marked it as some other color. This is only 9 as blue. So this is the left, and rest of it until root is the right subtrees in order post-order traversal. So let me write it here. So this will be 9, and this side will be 15, 7, 20. So let us write it here. Okay. So this is the top one is the Inorder and the bottom one is the post order. So now again we have to figure out the let's do the let's build the left subtree first. So we have 9 and 9, so it's just one number. So it's clear that we will have one node, so this will be 9. And let's build this tree. This is more interesting. So what is this? This is the Inorder traversal. And the next one is the post order. So in Inorder traversal, what is Inorder traversal? Left, root, right. So this so we can't figure out what root is from that. We see the post order traversal, left, right, root. So this will be the root. 20 will be the root. And so 20, let's write 20 here. And we find 20 in the Inorder traversal. 20 is here. So all of this, the before portion will be the left subtree, and all of this, the right portion will be the right subtree. And the left subtree's length is 1 here, so this will be the left subtree's post order, and this will be the right subtree's post order, just everything else until the root. So this is for the left subtree, and this is for the right subtree. So we pass it to the next levels. We build first left. So we have 15 and 15. So it's clear that we only have one node, which is 15. And here we have 7 and 7. So we take 7. So this is the tree. 3, 9, 20, 15, 17. If we see here, 3, 9, 20, 15, 17. So what we just did, we first we have figured out the root in the post order, which will be the last element, and we have found the root in the Inorder traversal, and we know that everything before root in Inorder traversal is left, and everything after root is right. So we pass it to the next levels, the Inorder traversal for left and Inorder traversal of right to build recursively. And from here, the length of the nodes in the left subtree is same in the Inorder and post order. We have used that to find the post order traversal of the left subtree. So here the length is 1. So this will be the post order traversal of the left subtree, and the rest of it until the root will be the right post order traversal. So we have used this, and we have built the tree recursively. So let's code it up. I will use a helper function, build tree helper, and we will pass. We have to know where the Inorder traversal starts and where the Inorder traversal ends, right? So to determine that, we will use some variables. So firstly, we'll pass Inorder, and we pass post order, and we pass Inorder start, and Inorder start and Inorder end. So Inorder starts at 0, and Inorder ends at index Inorder size -1. And wait, yes. Okay, next we have post order start and post order end. Post order starts at 0 and post order ends at post order dot size -1. And now this build tree returns the root of the tree. And next, let's implement the build tree helper. So tree node start, it returns the root of the tree, and build tree helper. Let's copy this. Vector Inorder and vector post order. And next we have int Inorder start, and int Inorder end, and int post order start, and int post order end. And now what we do, we have to do some checks here to, like in every traversal, we check if the root is null or not. So we do that checks later, but first let's do the main thing. We have to find the root. Root will be the end of the post order traversal. So let's take tree node star root equal to new tree node of post order end will be the root. So post order of post end. This is the root, and we have to find the root in the in-order traversal. So let's iterate. Let's keep in root and in root index. Let's say it as in start for now, and we keep updating it when we found the root. So I equal to in start, and I less than or equal to in end, I plus plus. We iterate over the in-order traversal, and we check if the current index is the root value, and if it is, we make in root index. We found the root, so the index will be I, and we break. Now we have the in-order root index. Now we know the length of the left subtree in-order traversal, what it will be. In-order left length, let's say, and it will be in root index minus in start plus 1. Okay, so this will be the in left length. So if we take this case, then this is the root. So this left is at 0 and root is at 1. So 1 minus 0, I think it's just 1 minus 0. So let me remove this. So in root index minus in start. Now we have the root. We have to build the left and right subtrees recursively. So let's do that. Roots left will be equal to build tree helper, and we pass the in order and the post order first. And what will be the in start? In start will be the same. In start will be in start only. And what is the in end? In end will be the just before the root, right? Before the root. So in root index minus 1. And what will be the post start? Post start will be the post start only. And where will the post order traversal end? It will end at post start plus we add the post start plus we add this length, right? Post start plus in left length. So if we consider here, the post order traversal starts at 0 and we add the length, so plus 1. So post order traversal ends at 5, and we have to do minus 1 here. So length minus 1. So that we get this 1, 0, only 0 minus 1, because this is the length and we adding to the index, so we have to separate minus 1. Now let's build the right subtree. Right equal to build tree helper, pass in order, post order. And now what will be the in order start of the left subtree? It will be right after the root. So in root index plus 1, and where will it end? It will end at last. And the post order start for the left subtree will be after the ending of the left post order. So we can say here it ends, so we just do plus 1. So minus 1 plus 1 cancels, and let's take this over here. And then post order ends at post order end. This is the root index minus 1. Okay, so now we have built the left and right. So now we return the root. Looks good. Let's run the code. Okay, we have forgot to build the checks. So when will the root become null? When, if in order end, because here if we are at 0th position, if we done with this, then the in order end will become minus 1. So in order end will be less than Inorder start, then we are done. We don't have any more values. So we return null as our root. It resolved the issue and passed all the sample test cases. Let us submit it. It passed all the test cases. So what will be the time complexity? The time complexity will be the same as the any traversal. So here what we are doing a pre-order traversal. First we are taking the root, we are building the root, then we are building the left, then we are building the right. So the time complexity will be O of n, where n is the number of nodes in the tree. Number of nodes in the tree. And the space complexity will also be O of n, because we are doing it recursively, so there will be a recursive call stack involved. So the space complexity will also be O of n in the worst case. So the time and space complexity is O of n. So that's the solution for today's problem, construct binary tree from in and post-order traversal. I hope you have understood the solution. If you did, make sure you hit that like button and subscribe to Coding Charms for more problem solving related content, and see you all in my next video. Till then, take care. Bye-bye.